Hi everyone, this is Shivakant here. Today we will be discussing a medium level problem, which is Google Calendar. So this is something that I had done mock with some of the peers, and today I'll be presenting the final product from there. And thanks for joining. We will try to see, where all we can improve upon this design and have, a takeaway for everyone. So let's begin here. So the very first thing is the understanding the requirement, which is we want to build a Google Calendar. So here, what all things we are kind of thinking here is that there should be some sort of time slot for that, like start and end. Then there will be some sort of number of participants, like list of email IDs, and then we can have video links and maybe some hello message and all, invite message like hello. And another interesting thing that we would like to have is talk about the life cycle, like how do we send the invites, how do we block the calendar for certain invites, we respond to that, like accept, reject, maybe see an overlap in a meeting or no overlap, and maybe some sort of notification 15 minutes before the events. So this is largely the thing. So I'll go ahead and run through the clarifying requirements. So here in the clarifying questions, we will just clarify the requirements and see if anyone else has any other question and how we can improve upon the scope. So the very first thing is, do we want the clients to be just web browser, or we also want mobile app support? So we can say like we can have both, not a big deal. So another thing is like what kind of exploration do we want, like daily, weekly, monthly kind of, do we want some kind of view? So for simplicity, we can say that at least my day's calendar should be visible if we are building certain APIs. Next thing is the life cycle. So which is like what is the expectation of the life cycle? So it's simple only, like someone will send the calendar invite. The next person will receive an email on that calendar invite. They will respond and they can later on join on that calendar. So yeah, so does it make sense? Like is it in the right scope? Someone wants to add something, or kind of thinks that this is kind of is not aligning with what I'm thinking.
Yeah, so the life cycle you are saying, you send,
sure.
receive, respond, and join.
Yeah.
Okay. So it is only when the user clicks, right?
Correct. So this is one of the happy flow, basically, let me say. So there could be more, definitely. This is just a happy flow.
Okay.
Yeah. Just to catch up on things, that what exactly we are trying to achieve as part of the scope.
Okay, because I think first API will be about the daily, what you said in the exploration, and this will be another API, right?
Yes. So kind of we are trying to narrow down the scope in terms of via clarifying requirement. So what exactly the calendar means. So that is kind of a goal here, right? So okay. So the next thing is we are thinking that should we have some sort of scheduler for the next schedule? So for simplicity, we are not keeping in scope, though if someone wants it, we can discuss it out, because scheduler itself is a different system design. So we can say that we will use a separate system, maybe a subsystem, which is a scheduler service, and we can schedule from there. So just we can state out that yes, this could be done, but not in the time scope. So another thing is like, do we have to do some integration with Google Meet or Zoom integration? Maybe we can talk about, as a group, we can surface out some of these things. I don't have personal experience in integration. What I know is that this feature is provided by these parties. So concurrency, we will see like now what are the challenges, and what could be done, maybe the client side validation, server side validation. And the last part is like the scale that we are targeting. So let's say this calendar and scheduling, generally not every general public does it. It is more like corporate people does it. So we can say that there will be 10 million daily active users, and participant could be like a fan out would be 1:10. For instance, there is a manager or a tech lead in the team, they would send an invite for presentation, and that would be typically in the pattern of 1:10. And yeah, so typically a person will send 2 invites in a day and probably receive, I don't know, 1:10 is there, so they will receive maybe 20 invites or 10 invites in a day. In a day, we can have 5 different schedules. I think these 2 are not aligning. So 2 invites sent in a day. Yeah, 2 invites sent in a day, and maybe 10 received, and in a day we will have 5 schedules. I think it is fine. 5 kind of accepted schedules. So does this sound good? Like does someone think that, okay, I wanted to at least discuss this thing, or I think this is very much redundant? Why are we keeping as a clarifying question? Can we just put it to not in scope kind of thing? Like, for example, can I move this to not in scope?
So, but if there is some big event happening, like all hands meeting or so, then in that case, it will be used, right? One invite, and it will be.
Yes. So what we are thinking is this is an average, like average. These are like definitely average. Sorry for this jump. So these are definitely an average that we are estimating here. Yeah. So sorry. Yeah. Okay. Average participant fan out. So it could very well happen that I am just meeting one of my mock partners. So that will be just 1:1.
Single one. Okay.
Yeah. So that way. So any other question? Maybe someone can take a lead and help me out with any questions are coming in the chat, because if I hop there, it will be kind of distraction for me. So yeah, so let me then jump to the kind of the functional requirements here. So so far I don't know if I should fill something in the constraints. We'll think about it. So let's jump to concrete user expectation or functional requirement. So I'll build it as a user story so that it is easy to understand and grasp and communicate, and kind of break it into tasks so that our teammates could pick up and they can estimate it independently. So user should be able to explore their calendar. So this is like read something. User should be able to create, update, delete a meeting invite. User should notify the users. The system should notify the users via email of the invitees. The user should be able to accept, reject, or put on hold these meetings. The system should notify the user X minutes before the meeting. So I'm just fixing this as a 10-minute. I'm getting 10-minute some notification. The system should tell if while creating or accepting the meeting, if there is an overlap. So this is kind of some sort of client validation we are thinking. So yeah, so this is largely the thing. So now jumping to the non-functional requirement here. So the very first thing we are thinking is that we can have the availability, which is like we want maybe 99.9% availability. The next interesting thing is availability versus consistency. So I think we had discussed this problem a while back. So anyways, so this session, I hope this is not a repeat, right? We are doing it fresh, right? Just confirming.
Yeah, it's fine.
Okay, cool then. So so there was in one of the session we had really a long discussion on consistency versus availability. So here I'm thinking that for calendar we should have higher consistency over availability, especially while blocking, because we do not want that one of the person sees the invite and they miss the invite just because the system was designed for availability and one of the team members could not join it. Rather, we would if the client or the web browser is not able to see the page or open the page, it can say that the system is down. Really sorry, we will not be able to schedule the calendar or meet on this system. So that way, at least your manager is aware that the system is broken right now, so he can schedule it 30 minutes later or something like that. So another thing we are thinking is whatever is scheduled here, it should have really high kind of durability, and whatever information is stored, it should not be kind of lost per se. Like we want to go to history and just want to see, and the read write ratio is like 10:1. So most likely we'll get a really good cacheability. Yeah. So here 90% cacheability we can get. So yeah, and reliability and maybe some other things we are kind of parking here. So now I'll be going through some of these API expectation, which is like we will have some sort of calendar service endpoint with we will typically have a REST interface. So here it will be like let me just draw like this. Yeah. So here it will be like calendar/v1/schedule, and we will just say use some authorized key, and then start date and end date. Based on this, it should return the calendar details, and just for maybe just for fun, we can have some sort of sorting. Basically, some sort of pagination has to be there, definitely. And can we have sorting, filtering, and pagination is there, right? So sorting will be already there, which will be like ascending order. And filtering, yes, filtering also we can do. For example, I mean, it's not in the scope, but we can have specific categories. Like I can have interview calendars, and we will just tag it with interview calendar, or maybe personal calendar, or kind of job calendar, and that way we can just show those calendars which are applicable here, just for the heck of covering the big picture. So the next thing is the create, update, and delete API. So this is again, it will be some sort of calendar v1 and scheduled, and this will be a post API here, and we can have some action like create, update, or maybe delete, and based on that we can pass certain parameter like start time, end time, who's the owner, and the participant list. Like suppose there are 10 people who are part of this email list, and so they should be notified, and there will be some personal message like hi everyone, or hi XYZ team, this is a good time to catch up and see how we are progressing at the end of the sprint, or whatever, or maybe fun time, something like that. And then in the metadata, we can have some sort of a meeting link, Zoom link. If we are able to actually do some sort of integration, then we can have actually some hash ID or full, URL sort of thing, other URL we can have. So that will kind of help us, get those information. For example, I'm embedding an image or something like that. So the last part of this API is yeah. So here basically the receiving person can just on the same schedule, they can say a confirm action, and then this is the meeting ID and this is the email ID, and they will kind of accept. So till this point, any doubt someone feels that okay, this could be another improvement here, why we didn't do this, or what is the reason for especially choosing this or that? Any other queries? Okay, so if there are no queries, I'll just kind of jump from here. So this is basically
one quick question regarding your durability. You mentioned that's 99.99%. So why do you think that it should be 99.99 only?
Okay.
In what scenario? In what scenario do you think that you will lose your data?
Sure. So just going a deep dive on this. So I mean, I was also discussing this with one of my kind of mock buddy. So first of all, what is this number state? So this actually states that what is the uptime or availability of a certain system. So for instance, let me just open up. Just give me a sec. I'll just
So to me, durability, I mean, my definition could be different from you. So you just say that availability, but I'm thinking that your data is persist and it will be available. You will not, or the person will not lose his or her data.
Correct. So this is basically the underlying data that we are keeping will be safe. Basically, that is what our assumption is. So yeah, so this is our assumption. So here the goal here is that that it should be beyond the availability. For example, even if the system goes down, can we have can we have the data stored safely somewhere? So I mean, we can just say that we will directly store it in S3 and kind of get maybe 10 or 11 level of nines, but at least in our own system we can also think about it. So we can definitely store some snapshot there just to restore, let's say, our whole of our system or all the 3 replicas go down. Then what? So here maybe I'll state via this. So we have this availability numbers are there. So are you by any chance interested in going into that detail, like how much is the uptime and all? So here
I'm interested here that about the durability, in what scenario we will lose the data. So that is actually the red flag to me, that we are saying that we may lose your data. So in what scenario we may lose your data?
Sure.
Not the availability, but about the durability part.
Sure. So the very first thing is, let me kind of just take a little digression and kind of detail it out. So the ACID definition that is stated in the 1970s, it says that your system is durable. So though we say that it is durable, there is an assumption that is 100% durability. But because in those days, people were just thinking that, okay, I record this data and I'll just put it in some tape drive and there is a guarantee that I will be able to recover, but this is mostly an assumption. No system could be 100% of that attribute. So now what we have to do is we have to actually kind of design or give some hard thinking here, like how much are we, actually achieving here. So let's say, I'll just touch upon those things just in next 2 minutes. Let's say that, one in some, 10K, HDDs crash, crash every day. So this is some sort of number is there. So, here it means that this is actually giving me maybe just 99.9% of the durability guarantee, right? This is my understanding. Is the calculation right? Yes. So this is, I think this is this itself is able to give 4 lines, at least what I'm seeing here is. So let's say if we are able to provide 3 replicas here, and so basically we want to just go a little more there, and with 3 replicas we may be able to kind of get more level of nines. I know there could be more tricky maths here. It will require a bit of more due diligence, but kind of we will keep it in mind. That's always my thought. This is kind of an assumption. That is what my thought here. I mean, exactly calculating is a little difficult. So from this, it looks like this itself is 99.994. So what if, kind of, if I put 3 replicas, then it definitely it will be more. Or can I take, regular snapshots? Then what will be the durability? So maybe, it will definitely ramp up, right? So let's say every 5 minutes, I'm taking a snapshot. So the worst thing I'll get is, loss of 5 minutes of data. So what is that number if I'm getting it in a year? So from there, we can kind of cross relate here, right? So this is what my goal is here regarding this system, whether going much into deep dive. So hopefully at least I threw some light for everyone's understanding, right?
Yeah, thanks.
Okay, cool. So let me go into, yeah, please.
So what about latency? Like, let's say somebody initiates the meeting, right? So that should.
Okay, sure. Yeah. So what I'm seeing here is that typically calendars, I mean, in a typical setup, the calendar, even if we get the calendar invite 5 seconds later, typically the calendar invites in a good adjustable world should be at least notify me 30 minutes before or notify 1 hour before, right? So let's say I'll put that. So let's say that I have a latency requirement here. So in an ideal setup, basically the meeting would come at least 24 hours before, and the best or like the worst we can get is at least 5 minutes before I will get the meeting invite, right? So the latency, there is not much of a concern. That is what I'm seeing. So there is no dire need to optimize it, so to say. As long as we are able to take the throughput, as long as we are able to get the consistency, availability, and durability, latency does not look like a big concern to me, right? Okay. Anything else? Anything else?
No, I think this is fine. Yeah.
Okay, cool. So let me jump to some of the data models. So, do you want me to jump to the high level design and maybe come back to this?
Well, we can go through data models, right? And then.
Yeah, sure. Let me go. So there aren't too many things. So here, the simplest thing is there will be a user entity which will have some ID, maybe 1, 2, 3, and then there will be some email ID associated, and maybe whatever other attributes there that we are interested, it will come here. The next thing is the meeting entity or the mini meeting entry. So meeting will have a couple of things. Like the very first thing will be it will have an ID of long data type. Then we will have start time of some date time. Then there will be end time will be there, and then there will be an owner. Okay, what is this timestamp? Okay, I'll come to this. Then there will be owner who created this meeting entry, and then there will be a list of participants. Then maybe subject and message and some meta like meet link. And the very next thing is we will have a calendar entry in each for each person's schedule entry, right? For example, I'm part of this meeting invite. So in my calendar, there should be I will have my user ID associated, and then I will have the meeting ID associated. So this will be kind of the link between the two, and it will connect that, okay, I am part of this meeting. So I'm part of this meeting. So, I'll be sent the invite, or I can just view this information. So largely this is the thing. And just going a little maybe inside, like we can have, user ID and email ID. So kind of user ID will be 8 long bytes. So this is what we will typically, refer as kind of foreign key everywhere, wherever is necessary. And we will not directly refer via email ID because that could be much longer. So this was kind of discussed somewhere. So yeah, and yeah.
Are
so
we
now
taking care of this recurring meetings also?
Recurring meeting is not covered here. We can think about it. Maybe shall I put it in expectation? Can we design for recurring meeting, and we'll see. What does it take? Maybe at the end of the session. Yeah.
Okay, sure.
Yeah. What about a recurring meeting? So yeah. So we can discuss this kind of, and let's see how it comes out. So yeah, so we are here. Let me now directly jump to this part, which is the underlying system or high level design to achieve this thing. So the very first thing, or the simple API I will explain first, is there is an actor who will do explore call. So this exploration will call the API gateway, and from here it will go to the underlying. It will do some auth, email, and it will inject some user ID and things like that. So it already knows that I am logged in via my web or app logged in, and it will do some sort of authentication, authorization, rate limiting, and whatever it wants to do. Then the very next thing is that it will hit the user service, and from there it will do the underlying kind of authentication, authorization. So as part of the explore, what it will do is it will go here. One second, where is this coming? Okay, so it will go to the web server, it will go to the calendar service, and then it will basically go to this search service, and it will return the underlying calendar details. So this is largely the search. The next one is a send, which will send the underlying information to the calendar service, and here it will do the sequence of events. So it will first of all do some sort of client side validation, which will be like if you have no email invitees, or the subject is empty, or you have a missing calendar link, so it can suggest that, hey, do you want to add the calendar, or auto suggest the link for this based on the participant. And then it will also check for some time overlap. Let's say that you tomorrow the same time I already have a meeting, and I'm also blocking for this group, right? So it will warn, hey, you already have this, so I have to cancel this or that, and then move ahead. Then so these kind of validation we can do, and it will then basically send over to the server for the same set of client validation plus kind of overlapping, and it will store the information in DB, and it will create some schedule and notify the recipients. So this will be kind of some sequence of events for sending the calendar. So it will come here, it will create the meetings, and after creating the meeting, it will the next step is it will create the calendar, which will be an entry for each user, specific user, basically user and meeting kind of entry. And then the third step will be it will store in so it will store in the DB basically for query purpose, and then it will trigger the schedule service and also the notify service. So so does that sound good? One second, something weird has happened.
So what's happening inside the calendar service?
One second. Looks like my headphone battery went away. I'll just put my headphones, wired headphones. Hey, am I audible? Okay, cool. Yes. What was the question?
So what's the job responsibility for the calendar service?
So calendar service is doing the main lifecycle orchestration of of the calendar. So like for example, we want to do a range search of explore. So this is typically it will go to the calendar service, and from there it will do the range search.
So could you help me to understand that? Let's for the create one first.
Sure. Sure. Here, so here this guy. So this is basically the send invite will actually do a create entry here, right?
Okay, so what will happen? I want to understand that what will happen when the create request reach the calendar service.
Sure. So it will do so the calendar service is the kind of the central orchestrator here, and so what it will do is it will do certain set of sequence of events. So let me kind of very explicitly maybe match one by one. So the very first thing, it will do client validation, and then it will do server validation, and then it will store it in the DB and create some schedule and notify the recipients. So these are kind of these are kind of the intents that it will do. Now how does it achieve it here? So in more kind of fine-grained thing, the request once the client validates the request, it will come here, and the calendar service, what it will do is it will first create the entry in this thing, basically the meeting DB. So this is a meeting DB which we are also kind of taking a snapshot every maybe 5 minutes. So here so the next step would be after we discussed about that meeting model, right? It will create an calendar entry here for query searching and all. And yeah, so here, this is, I think this is a cache. Yeah, this is a cache for the calendar service. So if someone wants to,
so you're saying that the calendar service will create an entry in the meeting entity meeting table, right? And then it will create the corresponding invitee entries in the calendar table, right?
Yes. So yes.
So where is the failover scenario that when, let's say, after creating the entry in the meeting table, this service crashes?
Sure.
Just one basic question. This calendar service is going to send the invite only when the request is created, right? It's not going to send an alert 5 minutes before the meeting is going to start, right?
Yeah. So so what I think typically what I've seen is that the system does that. So maybe there will be some sort of link. So this scheduler service can actually do that part here. So let me kind of, this will be the first, this is the second. So this is like, let me say the third part of it, the third step here in this world. And then this will be kind of the fourth part of it. And that's all done. Schedule the event. And this would be kind of an external system. This is not much of interest as part of the big picture. That is what I feel. Yeah, so this is basically the core of this. This is more like external.
Yeah, schedule service is a complicated piece.
Yes. So that's why kind of, so I have another session for schedule service already. So now maybe in the next sync up, we can discuss about that and drill down on that. So not as part of this scope. So this is largely the thing that, kind of, yeah. So does it make sense? Like, is any other concern, questions, and things like that?
One thing, let's say request initiated a meeting, right? But that got failed. So do we need to have some kind of queue which would store the request so that in case it fails, the calendar service can again pull it from the queue, something like that? Or again, the one who initiates the meeting, he'll have to create another request?
So what I'm thinking is this is very a human, interaction sensitive kind of application. I create a calendar, like this happened like few days back with me. So I had pinged one person, and we wanted to meet, and we verbally committed that, hey, let's meet tomorrow 11:30, whatever. Okay. So what happened is kind of there was no confirmation on that, and the person's mobile app from where he or she had created, it did not send the information to the backend, right? So because it was not sent to the backend, I did not get the invite, and I actually booked that slot with someone else. So that is kind of a gap in human understanding, where when we are doing a calendar booking or any third party unreliable information, we have to get feedback there. We cannot just say that, okay, I created a meeting and other person would have got it. Now wait for that confirmation. So in that regard, what I think would be a strong model would be, let the person create the invite, and unless this is all is done, don't acknowledge it. Let it take time. There is not much of a hurry. You can just say, scheduling take 2 seconds. Who is dying anyways? Because that there you will be spending. I mean, I'm just being too blunt here, but let it even take 100 milliseconds, 500 milliseconds. It doesn't even matter, because you are scheduling for half an hour. So can't you even wait for 2 seconds, right? Just for scheduling purpose. So I don't think, also this is like mostly human initiated event will be there. Like we will not have a robotic scheduling. So all the participants are also human. So anywhere there is a latency. So what I think is it should be sync, and latency is not much of a concern. That is what I'm thinking.
So like we could have used some sort of queue between web server and calendar service, right? Let's say in case if it fails, the request you couldn't update in your DB, right? The next time again, I mean, because of that, the user will not get a ACK, right? So for that, again, user will have to initiate a meeting, right? So would that be the responsibility of the client, or do we need to have something in between web server.
Sure. Yeah. So yeah, sure. So let me kind of think it out. So this is more like the reliability concern. So what if the calendar service is down? Is this kind of a very straightforward and blunt question?
Correct. Yeah. It couldn't update in the DB regarding that. Yeah. Calendar service.
So there are
is that as you are giving all the responsibility to the calendar service, and you will make it succeed that only when calendar service make an entry in the meeting table, as well as create all the entries in calendar table, and it could be maybe one entry or 100 entries based on the invitees. Correct?
Yes.
So if some invitee fails, what will happen?
So again, that actor will have to try it out.
Okay, that is I think a very good question. So yeah, so let me kind of now create calendar, and let's say if there are partial failures. So what all can we do here? So kind of let me elaborate. Maybe the very first thing is a meeting entry could not be created in the table. So what can be done? So the thing is, it will be kind of, and in the sync model, it will be like a fail fast. So now the thing is, if we could have taken the request as a queue, we could have processed this thing in the backend. Yes, I agree. But how would we tell the kind of the owner of that calendar that, hey, your meeting was finally booked? Like the person is kind of waiting to see that, okay, I actually am able to lock everyone's calendar, right? For example, think about it, like we were doing all the client side validation, which was checking actual availability of the slots. So now if we are spending maybe 2 minutes, if we can spend 2 minutes to schedule, basically identify the overlap and all, to why can't we wait for this? Okay, wait for it to complete. So if it fails, the person can retry, right? So on failure, they can retry, right? So this is what I'm thinking. I mean, if we do it queue based, what will happen is, like the person will not get immediate response, and for how long the person has to wait, we don't know. It's basically, typically people would like as soon as possible on best effort. So ASAP and best effort. So that is more aligning to sync kind of model, where, okay, I book a meeting at 9:30, it is 9:15. So let me just book it and then get quickly confirmation, here your meeting invite is created, kind of. And so, and another thing is, what I understand, the scale is not very big issue here.
I'm thinking here, I'm just curious to understand that. So when a corporate send an email to all the employees.
Yeah.
So,
sure. Why not?
They get the response immediately. The corporate may have, say, like 100,000 employees, so they don't wait for create 100,000 entries and reply back to the creator.
Yes, I understand. I think this part, maybe the calendar entry will be created. I think this part could be, because 100 scaling here is putting a lot of load on unnecessarily calendar service. So I think not here, but probably here we can have some sort of queue-based mechanism that might help. I think that kind of makes sense.
I do agree. Because another reason what I raised at the failover, so like it create an entry in the meeting table, and immediately after creating the entry in the meeting table, the service crashed.
Yeah. So at least here it is kind of making sense to me now, because here like the scalability part is like it is. I mean, I can't wait for 100 entries to be updated, right? Yeah, so kind of it makes sense. Let me just kind of for the heck of it quickly update this. So any other question here? I think this definitely adds some value here.
So where are
anything
we
else?
Overlapping part, like 2-person booking at the same time.
Okay, 2-person. Yeah, just let me come on that 1 second. So at least this part will be covered here. I think this indeed makes sense. Let's kind of see how we are able to get the durability here, but strong, all the guarantees here, but this actually makes sense. So yes. Yeah. So what was the another question? So here I think adding a queue does not kind of make a lot of sense, because we have to first commit the meeting, and maybe after that we have to we should tell the underlying requester. It should not be that the system takes the request and it tells, hey, I've already booked your meeting. Or if we set up the callback, there is no clear pattern of callback here, because the requester may be sitting on a web browser, which may not have kind of two-way communication, or they will just schedule a meeting on the app and they will just move on. So callbacks would be complicated. So I think it should just tell that missing meeting scheduling, like, just the what first part was done, and it can acknowledge here, and this could be kind of a second thing. So I think this kind of adds a lot of value here. So and this will become a serving layer. So from here it will I think then I can split the calendar creation service and calendar search service. So that way we will get additional fault tolerance. Like when we ask this question, right, what if calendar service is down? So we can say that we have calendar search, calendar creation lifecycle service, and maybe we will have calendar search service. So this search service will read from here. So that could be an interesting thing that we can do as part of this enhancement. So let me just put that component. Yeah. So I think that adds some value, right? So this will be served via this.
So what are we updating in this white column DB from Kafka? That scheduled meeting, right?
Yeah. So this is actually the individual people's calendar. So here, what is the intent is that people would like to explore their entries based on the dates. For example, last 1 week, how many calendar invites I have, or last 1 month, how many calendar invites do I have? So all those sorts of information could be kind of easily handled via a white column DB, where we will have the primary partition key. Basically, the partition key will be maybe the user ID, and yeah, partition key could be user ID, something like calendar _ user ID, something like that, and the sort key could be that it's just the dates. So that way it will be easy to kind of fetch those information. Dates, yeah, basically those specific dates of information. Like see, the thing is, we have, like, suppose I have 5 calendars scheduled today, and tomorrow 2, and then 10 calendar. So now if we use a white column, this actually provides a very easy way to scan through those days. Like I will just say, this is my user ID, and these are the dates of my interest. So whatever falls in that sorted entry, I'll get it in kind of order 1, right? Yeah.
And then
makes sense. Yeah. Yeah. So anything else?
And what is that use of that cache?
So I was thinking, like, maybe I can pull it here. So do I need to, this is search calendar meeting. So this is what I was thinking earlier, was that I don't need to hit the white column again, like, but let me just check where it is fitting here. Or
is it for recurring meeting? For recurring meetings and all, we can use it.
Yeah. Okay. Yeah. So this is for this is the DB, right? So yeah. So this is the DB, right? So now this DB will have the information of the meeting information. So whenever someone wants to fetch the meeting information, so it will not always hit the DB, because this could be slow, right? So why can't we kind of use some sort of cache? So we can use some consistent DB, like yeah. So we can use like a consistent cache, like Redis, and that can provide both the guarantees of strong consistency, and we can have a TTL with which if some of the information are getting updated, it will be also reflected here. And another thing is we can do some sort of like write through caching, so that way all the information are always updated here. So these are some ideas we can always kind of debate.
Sure. One question. So why do you need to search for the meetings?
Yeah. So let's say that so this is basically not the meeting. So here when we are storing the underlying this thing calendar, right? So this calendar entry will be complete only after it gets access to the meeting table. So this meeting has a special information now. This is not the meeting. It is just the meeting ID, the data model that we are discussing here. So this entry, basically, when we are talking about meeting, this is the entry that we are thinking. So we could give maybe some better name, I don't know. So this is the calendar. Your calendar will associate with a meeting ID. So this is the meeting that I'm thinking here. Yeah.
I didn't get, why do you maintain cache still?
Okay, so this traditional data store, it might take kind of 10 milliseconds to fetch the information, right? So the cache could provide sub-millisecond kind of latency, and especially the hot items. So what happens here is we know that most of the meeting, let's say this meeting, whenever I send it over, even if the first one is a cache miss, the rest of the people can whenever they are scanning their information, they will just read this information from here, the meeting ID for the corresponding calendar ID, and it will be, because of recency, it will be cached. So what happens is it is very time sensitive, right? For example, there is a meeting at 10. Most of people will log in at by 10, and they will log in from 10 to 10:12 or 10:13. And so with a 15 minutes of TTL, we can kind of get a really good cache cache hit ratio here without even write through, like just a simple cache with a TTL could also help. So okay, there are many alternatives here actually.
So you're saying, I mean, you're trying to build an app that will given a way to schedule the calendar, right? It's not like at the time whether people are joining or not. So when somebody is scheduling a meeting, so at that time, if you send it to all the users, and then those who are not online at that time, for them anyway, you put a queue to send it to them after some time. So for that sense, like, we don't need really cache, right?
No. So this is for suppose I want to join a meeting or something. So what I will do is what happens, like I cannot show my calendar.
Okay, but 1 second. For joining, you will be having the link already. So why do you need to worry about the calendar again at that time?
So for most practical purposes, what will happen is most of people will land to their calendar first, and from their calendar, they will fetch the meeting details, right? So that calendar in that hot period, like let's say, at 10, I had scheduled a meeting to join. So most of people will hit their calendar and explore their calendar. So this basically the search explore. Yeah.
Okay. So you're saying that. So you're saying that every time users will try to contact the server to get the meeting details, so they will not maintain any kind of caching on their end, the client side.
No. So why will so client it will kind of depend a lot on the underlying thing. For example, if it is a web browser, then there is no client side caching that will happen. So every time, let's say we have a meeting at morning stand up is 10 is there. So everyone will come in the morning, and the very first thing what they will do is they will fetch their calendar, right? So it will trigger this service, calendar service. It will get the 7 days of data, and it will also require the underlying meeting IDs for that. So for example, we are talking about maybe some XYZ team. So that specific team, all the people will see their random calendars, and 90% of that will lead to the common meeting ID. Like meeting has the real information, calendar is just blocking the calendar. So here this has like what URL to click, Zoom, maybe it is a room link, maybe it will have all the details like what is the status of the day, what is the actionable item that we want to do. So this is a common thing, right? This will be kind of heavily used. So since this is heavily used, we can cache those results. So this is mostly useful in the read flow. Kind of makes sense.
Yeah, got it. Thanks.
Yeah. So let me also kind of put a queue here because that will kind of clear some doubts here. So though not very meticulously done, but the thing is, let's say that we have something like this. I'll put it here. Sorry.
Hello.
Yeah. So anyways, so here is the email gateway. We will do it via some async. No need to kind of do this like this. Yeah. So anything else? Any other doubts? Like how do we handle scale? So this actually by splitting this, actually we are adding more value. Like if one of the things is down, for example, we are getting too many invites on the calendar creation service or calendar lifecycle service, then what will happen is it might go down. So still like can we have the calendar service kind of up and running, calendar search service up and running? So I think what I can do here is that instead of putting the cache here, probably I can bring it here or something. We can see, we can kind of motivate it out. So that way what will happen is that this calendar service, at least whenever it is serving, it will hit the calendar lifecycle service, get the detail, and it will do a cache here. So but it will be like too much information to keep. So I think let this guy only keep. There will be just some network call here. So this, at least to me, this looks fine. Any other question? Anything else? I think these two queues are helping us definitely. So yeah. Anything else?
There are calendars like in a meeting, if 3% are like 3% accepted the meeting, then then it is going to happen. Let's say majority of the participant doesn't even participate, or they rejected the calendar invite, then meeting is not gonna happen. So it will be rejected. So like a rare case.
Yeah, sure. So what we can do here is there are a couple of things. Like what we can do is, let's say someone rejected the meeting. So what will happen is, first of all, as part of their own like receive flow, it will be like client side. First of all, validation will be there. Like whenever you are getting a request, let's say morning 10 a.m. tomorrow, 3 people have sent you for one for whatever. Okay. So what you can do is before you accept that invite, it will do some time overlap validation. It will do, and you can also probably delete, add participant, modify, and like you can just do maybe message validation, and server side also this validation will happen. Now it's all up to you whether you want to accept the two invites in parallel, right? It will only be some sort of validation. Because somehow if you are able to join both, let's say there is a stand-up happening and there is all ends also happening, I mean, for whatever reason, you just can probably mute for 2 minutes and speak about yourself. I don't know. So that's on you to decide on the runtime, or just 2 minutes before you can cancel that invite. So if you are getting 3 invites, it's at the end of the day, the human's role to handle that specific scenario. It will only suggest, it cannot enforce you, right? So it cannot enforce you. Now let's say that, so there are a couple of life cycle we can think of. Let's say we rejected this. So what it can do. This guy here from here, the API will come and it will say that, okay, in your calendar, it will say rejected. And then the calendar's life cycle, what it will do is, the accept reject, what it can do is, it can send to the original owner this specific email, let's say user, and I'm just kind of overloading this, but just for the simplicity, user and email service, something like this. So this guy, what we will send the email to the other person, hey, I have rejected this, you plan accordingly. So here it will go here and it will kind of take the lead. Let me take this out here. So so I think it should not be that of big of a problem. And similarly, if one of the events are getting cancelled, let's say that the meeting itself, the original owner wants to delete the meeting. So before deleting the meeting, it has to search the underlying data store, and there will be some sort of definitely some mapping that to who all it has been sent, and it will delete those entries, and then it will delete the underlying meeting ID. So some a little bit of kind of coordination will be required, but in an ideal setup, it can do a cleanup here. And there was another question, like what if the meeting gets created and we are not able to return the confirmation, or meeting got created but the calendar events could not be created. So what could happen is, like, there will be very low 0.1% orphans will be left. So we can have maybe nightly job or something which will clear this orphans, like there is a meeting ID with no participant there. Yeah. So does this make sense, kind of? Does this make sense? Yeah. Yes. Okay, cool. Anything else, like on scale, reliability? So I think with this partitioning, at least we are able to make a bit of this thing. We can put a cache here as well, maybe just for its own local use. So, and that could help maybe, what it wants to cache, that we can kind of think about it. So this will actually help a little bit on wean out the too much dependency on things. So can we store cache info, this meeting information here, cache the meeting. So this is just a thought, like there could be consistency issue unless we want to be. I think we want very strong consistency. So caching here would be wrong. So let me undo this. So yeah. So what else? Anything else? So if this goes down there will be certain dependencies, of course. So if you want to do scaling as another part, so each of these components will have their own replicas, of course, and some of the components where we don't know what is the X multiplier here, right? For example, it could be fan out could be 1:2. I had stated 10, but let's say 1:100 fan out is happening. So better not this guy do, because it will get stuck. So let's do it with some sort of async model. So here I'm thinking that this will be the scheduling, at least it will do with sync, so that the information does not get lost, but we can again debate around it. If we feel that this will unnecessarily add additional latency to this guy, then we can debate it out here. Yeah, and anything else?
So what's the single bottleneck in this system? The database, that is going to be the bottleneck?
Looks like that. So let me think around it, like what are the challenges. So let me go into the scale. So I think I'll do maybe the estimation here as part of the document. So the scale estimations that we were thinking was, the very first thing was that we will have how many 10 million daily active user. Yeah, 10 million daily active user. And all these will fan out to maybe 10x will be the fan out. So even in the spike, let's say spike will be 10x. So yeah, so this is the fan out, and fan out to per user impact, and this could be a spike on traffic. So let's calculate what it is coming to. So this is coming to how much? Like actually it is coming to a pretty huge number. So 1 billion events kind of we will get per day. So this actually sums up to roughly around 10 to power 9 and 10 to power 4. So this is coming to 10 to power 4K events per second. So now what we can do is, this is the max that we are thinking. Now the actual source is just very small. So this is 10K events, but the source, the meeting information is very small. So the meeting information, like core meeting information is maybe just 100 meeting creation per seconds. So this is non-spike, I'm thinking. So even in spiky setup, how much is it coming? It will come to maybe 1,000 meeting creations per second. So this should be manageable in a relational DB. That is what I think. So yeah. Yeah, able to take the load. So there are certain like caveats or interesting things as well. So this is what we are thinking, that this is whole of the world, corporate world trying to do emailing. But what we can do is just for the scaling purpose, we can shard the information, right? So we can shard at org level, and for each org, it will be just 100K users, right? So now we are seeing that the scale is really small here. So what another thing we can do is shard at region level. So for example, like US will have dedicated servers, and maybe if it is India or whatever, they will have dedicated servers. And anyway, I mean, whoever is used to Outlook world and all, we know that the server sits at a single place, right? So let's say this like the main server sits in US. So it should not be a big deal, as long as we are able to communicate with that server, create the underlying calendar lifecycle, and then do whatever fan out. So per org level, this will be very small only, like 100K kind of, which is like 100x smaller. So sharding and all is pretty easy here. Region wise and kind of org wise, and maybe some other things we can do. So with that scale, any relational DB will easily take up the scale, right? Compute is not that of a concern.
And we don't have to read this database.
Yeah, so we have to read this database, but what happens here is, let's say that we have already shard at org level. So all those orgs, what we can do is, maybe the bigger organization, let's say we are building it for Microsoft or Google, we can have dedicated full deployment or maybe some sort of tenancy. And for smaller ones, we can probably share it, share the table. I mean, not exactly the table, but share the resources and kind of live with that. Any other questions? So here a couple of things, like we are thinking, me with our buddy were thinking like relational versus white column. So indexes are always sorted, but data is not. So like we can, how soon can we fetch, and kind of what will be the better approach for search and all. So this is what kind of we're thinking. Another thing was like calendar read API. The client will be so client can have a local cache. So this is, I think, so for instance, for app we can have a local cache, and so this will be app. Yeah, so app can have a local cache, and it can do some sort of polling per 30 seconds, or maybe some sort of push from the server. And for web, it will be most likely HTTP get or pull based model will be there. And there could be some. So I think this is one challenging thing that we were discussing. We can kind of discuss here as well. Like, what if it is multi-master? So I think this is a whole lot of a different problem, where on the mobile you are trying to set something, on the server you have a completely different information, and you on the web you want to also kind of create certain information. So what if there are competing concerns? So how will it work? Yeah. So this is what I know of, that I have a calendar, and even if multiple people are creating at the exact same time, and I'm not able to validate, so I will allow to create. So there will be duplicate. For example, I accepted 2 events at 9 a.m. I'm fine as to take. It's my personal decision. Or if there is a systemic kind of lag is there, for example, there was an app which was not synced, mobile app, then it will arrive on the right time, and we will have to take it up. So yeah, and recurring meeting, what we can do, store, create static dynamic conflict resolution. Yeah, so SQL, some partitioning strategy. We can have separate deployment, maybe a tenancy, domain specific. We can have a region specific kind of. We can have consumer tiers, and yeah. So largely these are the things, and some part we can have sync, async, and things like that. So I think we are already done with this. So any other question on this? I think we can almost close this, yeah, in the benefit of time. Yeah. So this is what we have come up with, at a big picture of moving pieces.